Hello students, in today's class we are going to learn about the event of an experiment, right? In the last class we started learning probability and we have seen what is meant by a random experiment and how to find the sample space of the given random experiment, right? In today's class we are going to learn about event and its various types and the algebra of events and some other things related to events, few other things, right? So what is meant by an event? Event is a subset of the sample space. Event is defined as the subset of the sample space. Actually, sample space serves as a universal set for our experiment, right? And any subset of the sample space is called as an event. In other words, the element of is corresponding to the occurrence of this happening, alright? And E is a subset of the sample space, right? So we will define any subset E of a sample space as a event, right? Then when we will call the event has occurred, when we will say the event has occurred, the event E of a sample space S is said to have occurred if the outcome of the omega of the experiment is such that omega belongs to E. If the outcome is such that omega does not belongs to E, we say that the event E has not occurred. For example, throwing a die. Consider the random experiment of throwing a die. Okay, so what is the sample space here? 1 to 6 numbers. It can be any one number among 1 to 6. So 1, 2, 3, 4, 5, 6 is the sample space there, right? Now my event is getting an even number. Getting an even number is my event. Now after throwing a die, suppose if I get 1, then 1 is not an element of my event because my event is getting an even number, but I got an odd number, right? Therefore, the event has not occurred here. So if I get any one of the even number, then the event has occurred, right? Now let us see the different types of events, right? Events can be classified into various types on the basis of the elements they have. First one is impossible and sure event. This is very familiar to us. We know right from our earlier classes. Impossible event means the event cannot occur out of the experiment, random experiment, which are we considering. And sure event is the occurrence of the entire sample space. And we know the probability of an impossible event is 0 and probability of a sure event is 1, right? For example, consider rolling a die as our random experiment and the number appears on the die is a multiple of 7 is my event. That event cannot happen. Therefore, it is impossible event. That type of event is called as impossible event. Then what is a sure event? The number turns up is odd or even. It can be an odd number or even number. So whatever number turns up from 1 to 6, it can be either even or odd only. So it is a occurrence of the entire sample space. So that is the sure event. Yes, hope you got a better idea. Impossible event and sure event. Next is simple event. What is simple event? If an event E has only one sample point of a sample space, it is called a simple or elementary event. What is meant by only one sample point? If the event has only one element out of the sample space, if the event has only one element out of the sample space, then that particular event is called a simple event. Okay. For example, they have given you, see, tossing two coins, the sample space we know head head, head tail, tail head or tail tail. Then each one is a simple event. Each event of getting exactly two heads is H. This is a simple event because this event has only one element. Okay, HT is a single element and therefore this is also a simple event. So each element of a sample space comprise of simple events. Yes. Next is compound event. What is meant by compound event? If an event has more than one sample point, then it is called a compound event, which means if an event has more than one element out of the sample space, then it is called a compound event. For example, exactly one head appeared when 3 coins are tossed. when 3 coins are tossed, exactly one head appeared, these 3 elements, right? HTT, THT, TTH. All these 3 elements have only one head. So these 3 elements will come under the event E. And if you see, there are more than one element in the event. Therefore, this is a compound event. Hope you got the difference between simple event and compound event. Simple event means there can be only one element inside that event. Compound event means more than one element in that event. Okay. When it comes to set, we will call it as element. Here we will call it as a sample point of a sample space. Right? Hope you got it. So we have seen 3 types of events. First one is impossible and sure events, simple event and compound event. Now let us move on to the algebra of events. As we do the algebraic operations on sets, we can perform some operations on events as well, right? So when we combine, we have union, intersection, difference, complement, etc. right? So likewise, we can combine 2 or more events by using the analogous set notations. As we use in set notation, the same type of things here also we are going to use. So to start with, we will take complementary event. In set also we had complement. We will denote it by dash, right? If A is a set, then A dash is its complement. How we will differ A? If A has element 1, 2, 3 and if the sample space has element 1 to 10, universal set, then A complement. A dash will have the elements which is not in A. Not A only we will call it as A dash or A complement. The same meaning here also it holds. For every event A, there corresponds another event A dash called complementary event to A. It is called the event not A. The event not A, which is not in that event. The element which is not in that event will comprise complement of that event. We will call it as not A. Okay. See here for example, they have given you the sample space of 3 coins tossed. A is HTH, HHT and THH. Only one tail appears. Clearly for the outcome HTT, the event A has not occurred. Right? But we may say that the event not A has occurred. Instead of saying the event A has not occurred, we will say not A has occurred, which means the complement of that event has occurred. Okay, hope you got it. Instead of telling the event has not occurred, instead of telling event A has not occurred, we will say not A has occurred, or else complement of the event A has occurred, because that is not our event, which means complement of that particular event, right? Next is event A or B. We know whenever we come across this R, which means union. R means union. Union of 2 sets A and B denoted by A union B contains all those elements which are either in A or B. That's how only we have done in our set. The same meaning holds here also. When we say either A or B or both, this event A union B is called A or B, which means the particular element belongs to the event A or to the event B or to both. Okay. R means union and means intersection. So with the same meaning here also. 2 sets A intersection B is the set of those elements which are common to both A and B, which belongs to both A and B. It should be there in event A as well as it should be there in event B. Then only it will appear in A and B. A intersection B. Right? Hope you remember all these things. These are all very basic things we have done in our set chapter. Event A but not B. What is event A but not B? Which means A intersection B complement. We are concentrated about the event A but not B, which means not B means B complement. So A intersection B complement, but it has a different name called difference. Hope you remember. A minus B is same as A intersection B complement. A minus B, what we will do? The number of elements, which is the common elements, leaving the common elements, the remaining elements of A we will write. That is called A minus B. How you will find A minus B? First we will strike off the common elements in A and B. Then we will write the remaining elements of the first set. If it is A minus B, we will write the remaining elements of set A. Right? If it is going to be B minus A, we will write the remaining elements of set B. Hope you remember all these things. So these are all the algebra of events. What are all the four algebra of events we have learned? Complementary event. Complementary event means not A. Not A, right? Next is A or B means union. A or B means A union B. A and B means intersection. A intersection B. A but not B means A minus B. A but not B means A minus B. A minus B is same as A intersection B dash, right? Next we are going to learn another important concept called mutually exclusive events and exhaustive events. What is meant by exclusive events? Exclusive events means the two events does not have any element in common. The two events are disjoint, completely disjoint. When they do not have any intersection elements, then we will call those two elements as mutually exclusive. For example, rolling a die. Consider the event A as getting an odd number, event B as getting an even number. Then they both are mutually exclusive. They do not have any elements in common. Okay. So then A intersection B is empty. Two events A and B are disjoint sets and we will call it as mutually exclusive events. Right. Then what is meant by exhaustive events? Exhaustive events means if you combine all the exhaustive events, if you find the union of all the exhaustive events, you should get the entire sample space. You should get the entire sample space. For example, consider the same rolling a die. The event A is number less than 4 appears. A number less than 4 means what are all the elements you will get? 1, 2, 3. Right? B event is defined as a number greater than 2 but less than 5 appears. Greater than 2 but less than 5 means 3 and 4. So B is 3 and 4. And C is a number greater than 4 appears. What is greater than 4? 5 and 6. So C is 5 and 6. And if we observe A union B union C is nothing but 1, 2, 3, 4, 5, 6. So which is nothing but the entire sample space. So here this kind of case we will call it as A, B and C are exhaustive events. A, B, C are called exhaustive events. When the events are called exhaustive events, when the union of the events gives you the entire sample space. Okay. There are possibilities for the events to be mutually exclusive as well as exhaustive. Which means what? The particular events do not have any elements in common. At the same time, if you find the union of all those events, we will get the entire sample space. Such a kind of events are called mutually exclusive and exhaustive events. Hope you understood, right? So what are all the things we have seen so far? What is meant by an event? Event is a subset of a sample space, and we have seen types of events. Under types of events we have seen 4 things: impossible event, sure event, then simple event and compound event. Impossible means an event cannot occur. Sure event means the entire sample space will occur as an event. Simple event means the event which has only one element. Compound event means the event which has more than one element. Then we have seen algebra of events. Under algebra of events we have seen complementary event, union A or B, event A and B means intersection. A but not B is A minus B or A intersection B dash. Right? Then we have seen what is meant by mutually exclusive events and exhaustive events. And one more thing you have to note here is all simple events are always mutually exclusive, because simple events means what? Every element of the sample space. Every element of the sample space, or else we can say any event which has only one element are simple events. Automatically simple events of a sample space will be mutually exclusive only. They will not have any elements in common, right? So based on all these ideas, we are going to solve our next exercise. Let us get into the exercise now. Now let us see the first question in exercise 16.2. A die is rolled. Let E be the event, die shows 4, and F be the event, die shows even number. are E and F mutually exclusive? So what is the question? Here die is rolled. So when a die is rolled, what will be the sample space? S is equal to 1, 2, 3, 4, 5, 6. Now the event E is die shows 4. So only 4 will be there in the event E. And FB, the event die shows even number. So what are all the even numbers? 2, 4, 6. So F is equal to 2, 4, 6. Now the question is, are E and F mutually exclusive? When two events are called mutually exclusive, when their intersection is empty, right? But here what is E intersection F? E intersection F is, we have 4, right? Which is not equal to empty. Therefore, E and F are not mutually exclusive. Hope you remember the definition of mutually exclusive. Mutually exclusive means their intersection should be empty. Alright, let us move on to the second question. A die is thrown. Again, a die is thrown. Describe the following events. A, B, a number less than 7. A number less than 7 means what are all the things will be there in A? 1, 2, 3, 4, 5, 6. All the numbers, right? And the event B is described as a number greater than 7. There is no number greater than 7. Therefore, it is empty. Alright. C is multiple of 3. Which are all multiple of 3? 3 and 6. Therefore, C will have 3 and 6. What is D? A number less than 4. What are all the numbers less than 4? 1, 2, 3. Right. And E event is an even number greater than 4. Which is an even number greater than 4? 6. So, which is simply 6. And F is a number not less than 3. A number not less than 3. The number should not be less than 3. So, what are all the numbers not less than 3? Not less than 3 means it can be greater than 3. Right? Greater than or equal to 3. Not less than 3. Strictly not less than 3. So, it can be equal to 3 or greater than 3. So, 3, 4, 5 and 6. Right? These are all the elements of the sets. We have described it. Now the question is, find A union B, A intersection B, B union C, E intersection F. Likewise, they have given you many questions. So first, what is A union B? Now what is A union B? A union B is the elements in A and the elements in B, which is nothing but 1, 2, 3, 4, 5, 6. The set B has no element, therefore A union B is this. What is A intersection B? A intersection B means the elements common in A and B. We don't have any elements common because B is empty set. Therefore, A intersection B is also empty. Right? What is B union C? We have to combine B and C, which is nothing but 3 and 6. What is E intersection F? The element which is common in E and F is just 6. D intersection E. What is a common element in D and E? No element, so it is empty. What is A minus C? A minus C means first the common elements you have to leave it and write the remaining elements of A. So what are all the elements in A minus C? 1, 2, 4, 5. Hope you remember all these things which we have learnt in our chapter sets. Then D minus E is also in the same way. D and E, there are no common elements. First step, you have to remove the common elements and then you have to write the remaining elements in the first set. We don't have any common elements, so leave it. Write the remaining elements in the first set, which is 1, 2, 3. Right? Now, the next question is E intersection F complement. So, first let us find what is F complement. F complement means the elements which is in the sample space which is not in F. Not F is called complement of F. In the F we have 3, 4, 5, 6. But in the sample space we have 1, 2, 3, 4, 5, 6. So the elements which is not in F is 1 and 2. Therefore F complement is 1 and 2. Now we have to find E intersection F complement. E we have 6. F complement we have 1 and 2. Therefore E intersection F complement is empty. Right? Hope you got it. So if you know the definition of all these things and if you were able to describe the event which is given in the question, you can very well do these problems. And if you remember the definitions, right? See the third question. An experiment involves rolling a pair of dice and recording the numbers that come up. So what will be the sample space when we roll a pair of dice? Then it will be 1, 1, 1, 2, 1, 3. We know to express the sample space of the experiment. It will be 36 elements, right? Now your question is, describe the following events. A is the sum is greater than 8. So if we add the number turned up on both the dices, the sum should be greater than 8. It should not be equal to 8. It should be greater than 8. So it can be, see, if you see the last element in this 7, right? 6 plus 1, 7. 5, 6, 7. 6, 7, 8. 8 also you should not take. Greater than 8. Now you can start with 3, 6. 3, 6 is 9. Then in 4, if you see, 4, 4 is 8. So we cannot take this 4, 5 and 4, 6. Similarly, if you come to 5, 5, 4, 5, 5, 5, 6. And when you come to 6, 6, 3, 6, 4, 6, 5, 6, 6 are the elements of A, right? And B event they have given as 2 occurs on either die. Either die means any one of the die, if it 2 occurs, all those elements will lie on B. Don't take it in the other way. Either die means not on both the dies. Either of the dies, it should be 2. So you can take 1, 2 because on the second die it is 2. And all the elements of this 3, 2, 4, 2, 5, 2, 6, 2. Either die means any one of the die it should show 2. So all these elements will come under B. What is C? C is the sum is at least 7 and a multiple of 3. Kindly understand, at least means minimum. Minimum it should be 7 and means both the conditions should be satisfied. And means both the conditions should be satisfied. It is, see, the sum is at least 7 and a multiple of 3. It should have the sum as minimum of 3 as well as it should be a multiple of 3, right? So if you add, you should get a minimum of 7 and it should be a multiple of 3. So 6 plus 1 is 7. It is not a multiple of 3. 6, 7, 8, right? 8 is not a multiple of 3. So then you have to check out for 9. 9 is a multiple of 3 and it is greater than 7, right? So 3, 6 will come, 5, 4, 4, 5, 6, 3 and 6, 6 are the numbers whose sum is greater than 7. At the same time, it is a multiple of 3. So we have described all the events. Now they have asked one more question. Which pair of these events are mutually exclusive? So mutually exclusive means their intersection should be empty. So we have to find all the pairs. A intersection B we have to find out. A intersection C we have to find out, and B intersection C. A with B, A with C, right? Then B with C. Thus we have formed all the pairs. So all the pairs we have to check. If you see A and B, do we have any intersection? No, we don't have any intersection. So A intersection B is empty, right? Then what is A intersection C? A and C, do we have common elements? Yes, we have 3, 6, 3, 6. Then 4, 5 is also there. 5, 4 is also there. 6, 3 is also there. 6, 6 is also there. Right? Then what is B intersection C? B intersection C, 3, 6 we don't have, 4, 5 we don't have, 5, 4 we don't have, 6, 3 we don't have, 6, 6 also we don't have. So this is empty, right? So A and B are called mutually exclusive events. B and C are called mutually exclusive events. But A and C are not called mutually exclusive events because their intersection is not empty. Hope you understood. Two events are said to be mutually exclusive if their intersection is empty, right? If you see the fourth question, 3 coins are tossed once. If 3 coins are tossed once, you know how to write the sample space. And they have given 3 events, 2 heads and 1 tail. Exactly 2 heads and 1 tail should be there. So understand the meaning and then describe your event. And then you know how to check whether it is mutually exclusive. If the intersection is empty, they are mutually exclusive. Simple means if the event has only one element, it is simple. If the event has more than one element, it is compound. So you can give the answer. And likewise, 3 coins with the same sample space, they asked you to describe 2 events which are mutually exclusive. These are all easy. After giving the sample space, you can easily pick up 2 events which are mutually exclusive. Mutually exclusive means the 2 events, they should not have any element in common. Likewise, you can describe. For example, you can write, let event A be having 3 heads and event B be having 3 tails. Exactly 3 heads and exactly 3 tails. These 2 are mutually exclusive. They do not have any intersection. So this is an example. Likewise, you can give any of your own example. Then they asked 3 events which are mutually exclusive and exhaustive. Exhaustive means if you find union of all those 3 mutually exclusive events, you should get the entire sample space. Likewise, you have to give the definition of the 3 events. In such a way, there should not be any common in all the 3 events. At the same time, if you find union, you should get the entire sample space. See, this is the sample space for tossing 3 coins. Now I have defined A as at least 2 heads. Events having at least 2 heads. Right? So minimum it should have 2 heads. So which are all the events will come under here? Minimum 2 heads. So H, H, H. Right? H, H, T. H, H, T. So these 2 have come under A. Then H, T, H. Then T, H, H. So all these 4 will come under A. Right? Then exactly 3 tails means this will come under B. Exactly 1 head. Exactly 1 head is there in TTH, HTT and THT. Right? TTH, HTT and THT. And if you see, all the 3 events are mutually exclusive because they do not have any element in common. At the same time, if you find union of A, B, C, you will get the entire sample space. So this is an example of mutually exclusive and exhaustive. Right? Hope you got an idea. But this is not the only way of defining the event. You can define it in your own way such that they should not have any element in common. At the same time, if you find union, you should get the entire sample space. Then only we will call it as mutually exclusive and exhaustive. Right? So likewise, you can give examples for all the remaining. Hope you can do this. Similarly, you can try 6th and the 7th problem. And if you have any doubts, you can ask me. Not B means complement, B dash. A or B means A union B. A but not C means A minus C or else A intersection C complement. Right? When you have 3 sets, you know how to do it. First find any 2 elements and then you can find. Or else since it's intersection, you can write what is A, B complement, C complement and check which element is there in all the 3 sets that will come under intersection of all the 3 sets. Right? Hope you can do this. So with this, let us wind up today's class and I want you to complete entire exercise as homework. I have done few things for you, but still I want you to redo it, and if you have any doubts, you can ask me. Thank you, students.